Hello and welcome once again. This is a tutorial how to use a multimeter. Now I know there are plenty of videos out there how to use a multimeter, but I want to point out some things, hopefully that are new things. With certain multimeters, you have scales. This one being a fluke meter, it's auto range. So obviously you've seen this type before. So if you need resistance, the unit of measurement resistance is an omega, which is this symbol. We put a resistance. If we need obviously DC, you see this flat one? That's DC. If we need AC, it's this one. How do we come to these things? Now, first of all, you've seen before that it says if you want to measure DC volts, you put it on this scale. Simple. However, we have to do something basic. Before you use any type of multimeter, whether it be auto range, whether it be the one that you have to put on the right scale, you always have to do one thing to make sure the leads work. These leads break over time, internally. Therefore, the proper thing to do is always to go, put this, before you can measure voltage, you put it on unit of resistance, which I have. This omega symbol is resistance. We have to make sure there's no break within these two wires. So we still always put it in, you see over here, in the jack, volts, ohms, and then there's another called diode function. The only one that stays, the lead that always stays in its place, is the black one, the common one. This one is the one that you move around always from slot to slot. Okay, now, what we do is we short the leads. When we short the leads, we should get, that's 0.2 ohms. Okay? 0.2 ohms, let me bring over here, 0.2 ohms. How do I know that the leads are good? You see that the number is not fluctuating a lot, number one. Number two, it should be less than 1 ohm. As you can see over here, there's the ohm symbol, and 0.2 ohms is a great reading. So that means between these two leads together, these two leads have a resistance of 0.2 ohms, which is very acceptable. What's not acceptable? Let's say when I short these leads together, and the numbers are fluctuating. You see how they're fluctuating up and down? That means the leads are broken internal. Change the probes. So the first thing is, before I measure voltage, any voltage, AC or DC, put it on this ohms. Make sure you get a good reading, a 0.2. Less than 1 ohm is surely acceptable. If it's 1 ohm, it's too high. Disregard the probes. Okay? That's why do we have to do this? If you're going to go measure voltages in automotive or anything, if the leads are not making contact or if it's broken internally, you're not going to measure the voltages properly. You're going to spend time chasing voltages and thinking maybe it's a ground problem or whatever. It's not. It's the leads. That's why you start off basics with multimeters. Make sure the tool works before you use it. That's that. Now, we said about DC. This is DC. Very quick tutorial. Very quick. What's the difference of DC and AC? Very quickly. You've heard it probably numerous of times. But I think the function is, we put it on this function as I showed you, the straight line. Now, we have always polarity. Polarity matters with DC. So if something is positive, I have to make sure I have the positive lead, the red one. If something is negative, I want to make sure I have the negative lead. We'll see it. This is a lamp. There are many symbols for a lamp. So in this, we have current flowing in one direction. Whether you have conventional current or electron flow, it doesn't make a difference. Current flowing from here to here continuously. Right? So current is flowing in the same path. Let's change that to the AC that we're going to measure. AC measure, it changes polarity. So we're going plus minus, we're changing the polarity. We're going this way, and then the current is flowing this way. This way, this way. The shape that we get over time is something called the sine wave. And this is the symbol that you see for AC volts. Meaning, sometimes it's positive, sometimes it's negative. How many times it does it is called the frequency. We have 120 volts, but it's called RMS. That means if I want to have the same heating effect as 120 volts AC RMS, I use 120 volts DC. Now, not to get too technical, its frequency is set at 60 hertz. This is by the electrical companies. So again, what's the difference? DC, one way. AC, this way, this way, this way. How many? 60 hertz. That means 120 times a second, this will change polarity and change direction. This way, this way, this way, this way, this way, this way. Again, for DC, we have a flat voltage, 12 volts. If this was time, 1 second, 2 seconds, 3 seconds, 4 seconds, it would always be 12 volts. That's why you get the symbol, the flat. That means it doesn't change. That's how you know this is DC. This one changes over time. Depending where you measure it, it'll be different. But what we have is, it's called a sine wave, and this is what we use. Okay? Now, if I want to measure the outlet, what am I going to measure? I'm going to measure, there's a hot, there's a neutral, which is the return path, and there's a ground, there's protection. Now, we said polarity matters with this one. You have to have positive and negative to a battery or a power supply. With AC, the polarity doesn't matter. If I put this here, or I put the black here, or the red here, or vice versa, doesn't matter. I'll still measure 120 volts, and we'll see it done. This is at the demonstration. Okay? I hope this cleared things up. A quick tutorial, so we know at least what we're doing. Now, let's get done with this. Hopefully show you something you haven't seen. Now, what range do we go to? We're going to measure AC. Which one do we go to? We just said the sine wave represents a varying voltage, so we go to this one. Okay? Now, the numbers will fluctuate, but see, this automatically tells you AC and in millivolts. What's it catching now? It's millivolts. We're going to go now, I'm going to put it to the outlet, and I'm going to show you something. Okay? I stick it in there. How much voltage is that? How much voltage is that? Sorry. That's 122 volts AC. Where do I put the probes? The probes still stay. Volts stay here. Whether it's AC volts, whether it's DC volts, this one stays here. And the common stays here to measure AC volts. Always remember, this one always stays. This goes back and forth. For AC volts and DC volts. I measure 122 volts over here. That's RMS. Fine, we know that's correct. There's one more thing you have to measure at the outlet that people don't know about. That's the frequency. This meter that you see measures frequency. We just spoke about, we have 60 hertz from the electric company. How are we going to measure it? You see this hertz sign over here? This is hertz. How much is this? 60 hertz. One part of the equation is we have to measure 120 volts RMS from the electric company. If not, we're getting ripped off. Other part, second part of the equation, we have to measure 60 hertz as close as possible. If I measure 50 hertz, I get on that phone, I make a phone call to my electric company and complain. It's supposed to be 60 hertz at 120 volts RMS, which is what we measure. Okay? There's two parts to the equation. Two parts to it. Remember, there's another part that you can measure called the percentage, the pulse width. It's like a pulse width on for automotive. It should be 50%. What does that mean? That means that the positive part of the cycle and the negative part of the cycle are even. This is even and this is even, going this way. So 50% is like a percentage of how much each one is conducting on and off, like pulse width. You don't have to do this, but I just demonstrating to you a point. Okay, now, what happens if I reverse the leads? Okay, you see, as you can see, I put positive and negative. What happens if I flip them? Okay, let's try to flip them. I'm a little new with this tripod, so just give me some time. I'm going to flip them. We said polarity doesn't matter. Okay? Now let's take it off here. Same thing, see? See? I flip the leads. It doesn't matter if I put the hot and neutral, positive and negative. If I put black lead here, red lead here, it doesn't matter. You're supposed to get 120 volts as close as possible, RMS, to that, as possible. Okay? Well, that's the point that I'm trying to make. It doesn't matter how you put it in, as long as you get 120 volts. Fine. Let's take this out. At 60 hertz, see? As close as possible to 60 hertz. Very important to get 60 hertz. Very important. Let's take it out. Let's show a point now. Okay? We took it out. Let's go here. Let's go here. Now, received an email from someone who said, I think I have a problem with my meter. I want to put on AC, it's on AC. The digits keeps on fluctuating. I don't get a steady reading with it not connected. See, these are not connected. Why am I getting all these numbers fluctuating on AC when I don't have it connected to anything, right? Well, these, believe it or not, the probes act as an antenna. So the signals in the air or around you are going to be picked up by these probes, which are acting like an antenna, and you're going to see that display. Now let's do something, okay? I just told you something. I'm going to put the light on. There's a light here, okay? The light is on. Here's the light. Now, see it fluctuating, right? Let's put on hertz. What is that coming from? See, I told you 60 hertz. That's coming from the light bulb that I just put on. So these are being an antenna, like I just told you, acting like an antenna, and this bulb radiates 60 hertz off of it. So if you have an appliance that has 60 hertz, let's say electric shaving machine or something like that, which is 60 hertz because you plug it into the outlet, this will pick up all the noise around it. This is what it's picking up. It's picking up the noise from the bulb that's radiating at 60 hertz. Now, let me turn off the thing because otherwise it's hard to see. What do? Zero it and make sure that you have 0 volts AC. So two things to remember. One thing, first, what do? Calibrate the meter. How? Make sure I'm on ohms. These work by shorting them together. I put this on AC volts. What else should I do? I see the numbers fluctuating. What else should I do? Short them together. Make sure I get as close as to 0 again. And you do. That's the proper way to do it, the proper way to measure. We're going to go in the next video. We're going to continue with the concept. We're going to do DC voltage. But before that, I want to show you something. Okay? Let me try to put this over here. Let me try to get this. Like I said, a little new with the tripod. Takes practice. But anyway, okay. We just said we put this in here. In this one. Okay? Let's not make a mistake. I try to put it in the other one where I'm supposed to measure current. These two are for current measurements. This is for voltage. And I have it on the volt scale. You hear that tick, 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 tick? You hear what the fluke meter is telling you? It's telling you have the probe in the wrong slot. Let's say I put it in this one now. Let me try this one. Let me try to adjust the camera. Let's say I put it in this one again, the amps. You hear that click, 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 click? It's telling you you're in the wrong slot. Because I have it in the volts. I should be where? I should be in this one. You don't hear the click, click now, do you? That's because I'm in the right slot. The best ones are the fluke. These are the standard of the industry for years. And even for automotive, I use it. You cannot beat this. This is the standard, how we measure standard. Even if you make a mistake, and we all make mistakes, right? Put this in the wrong one, it'll tell you, it won't let you. Until you put in the right slot. Okay? Next video is going to be about DC volts. I hope you stay tuned to the next one. And it'll be hopefully informative. Thanks for watching this one.